Welcome developers to the Explainer. Your CAPTCHA integration works perfectly during development, but what happens when it starts running inside a live production environment? Well, that is exactly the core challenge we're tackling today.
It's incredibly frustrating, isn't it? Many Elysia and Bun applications perform flawlessly in local testing, but then they begin failing in scheduled jobs, worker queues, or unattended automation. You wake up to late-night error alerts and support tickets. But here is the secret. The problem usually isn't the CAPTCHA solver itself.
It's literally everything around it. Just look at the stark difference between local testing and production reality. Locally, you're running a simple script on a completely happy path. It's a one-off execution. But in production, network hiccups, retry loops, session mismatches, and changing configurations take over. To succeed, we have to stop treating CAPTCHA solving as just a simple API call.
So, here is our roadmap for today. 1. The production reality. 2. The operational checklist. 3. Common mistakes to avoid. And 4. Developer FAQ and safety.
Section 1. The production reality, beyond the simple API call.
Section 2. The operational checklist. 7 rules for reliability.
Okay, here are the 7 production rules. 1. Validate request inputs. 2. Verify API responses. 3. Use efficient polling. 4. Keep the same session. 5. Limit retries. 6. Monitor workflow success. And 7. Design for future changes. Let's actually break down the absolute most critical ones here. Before you even submit a CAPTCHA task, you must verify that you're using the exact correct site key, page URL, CAPTCHA type, and any required action values. A surprising number of integration failures happen simply because of incorrect inputs, not because the solver failed. If you send the wrong parameters, you're just creating a false debugging trail for yourself.
Once submitted, you need a highly efficient polling strategy. Polling too frequently increases unnecessary requests, while polling too slowly delays your entire workflow. The sweet spot? Wait 15 seconds before your first poll. Then, use consistent 5-second intervals. Most importantly, enforce a hard cap, usually around 120 seconds, so tasks don't just hang indefinitely.
Now, Rule 4. Keep the same session. This is absolutely vital to understand. Session mismatch happens when you generate a CAPTCHA challenge in one browser context, but then submit the solved token using a completely different one. Guys, this is the absolute most common cause of valid tokens being rejected. The browser context and HTTP session must remain identical throughout the entire process.
Moving on to Rule 6. Monitoring meaningful metrics. Instead of measuring only successful CAPTCHA solves, you really need to track first solve latency, solver success rates, downstream acceptance, and your cost per successful solve. These metrics provide a much clearer, realistic picture of your system's health.
And Rule 7 rounds out our checklist. Prepare for change. Look, CAPTCHA implementations constantly evolve. By keeping your request handling modular, you make it so much easier to support different CAPTCHA types in the future, without having to completely rebuild your submission and polling loops.
Section 3. Common mistakes to avoid. Late-night alerts.
Let's look at the danger of unlimited retries. It is honestly a terrible idea. It hides permanent failures, creates infinite loops, and rapidly burns through your API balance. Instead, you've got to use a limited retry policy with exponential backoff. Retries should help recover from temporary hiccups, not obscure real defects in your code. Log those terminal failures.
Another massive mistake is measuring only API success instead of end-to-end workflow success. There is a huge difference between did the API return a token and did the downstream target actually accept the token. Getting a solved task back is definitely not the same thing as a successful workflow. Section 4. Developer FAQ and safety. Answering your top questions.
All right, question number 1. It is for sure the most frustrating, most frequently asked developer question we see. Why is my solved token being rejected by the target site?
As we highlighted earlier, the answer is almost always this, usually because it was submitted from a different browser or HTTP session than the one that generated the challenge. You simply have to keep your cookie jars and sessions identical. Question 2. What should I monitor first when setting up my dashboards?
Always start with end-to-end workflow acceptance. That is the ultimate metric. It tells you whether the complete process, from the initial request to the poll to session injection to the final form submission, actually succeeded.
Question 3. How does this affect cost as we scale to high volumes?
Well, volume scales linearly with successful solves, but the real cost killers, those are wrong parameter loops and retry storms. Applying this exact operational checklist drastically drops your cost per accepted solve because it entirely eliminates those wasteful infinite loops.
Finally, a really vital reminder here. This type of workflow should only be used in owned, client-authorized, or contractually permitted environments. This architecture is designed to make authorized testing and data collection reliable. It is absolutely not for circumventing protections where you have no agreement in place. Ultimately, your goal isn't simply to solve CAPTCHAs. The true goal is to build backend automation inside your Elysia and Bun servers that is reliable, observable, and highly maintainable as your application grows. If you found this checklist helpful, definitely explore the full implementation guide for additional technical details and production best practices, and follow along for future explainers. But I leave you with this. If your current automation is running wild with unlimited retries right now, how much budget is silently burning away before you check your dashboards tomorrow morning?